plane. So here we have the Volantex Phoenix V2, which is a 2-meter wingspan glider with the forward propulsion that comes with the plane. And then I upgraded to have a vertical takeoff and landing plane, so I adapted the booms. This one here that can carry the four vertical motors. So these pieces are mounted with some 3D parts that are on the file folder. So this is basically a 3-part piece. So you have the top clamp, the bottom clamp, and then the middle, which has the embedded nuts, which these bolts are going to be screwed in. And same here, we have a 2-part 3D mount that's going to mount the motor at the top and then clamp to the booms. So as for the motors, we have 4 Turnigy, what's the name? Aerodrive SK3, which is a 1200 kV, and they have a rated power of about 560 watts, and they require 40 amp ESC, electronic speed controllers. So all the ESCs are wired to the motors. There's 3 wires coming out of the ESC, 3 wires going in the motor, and if you have a problem with the rotation of the motor and you want to switch it, you only need to switch 2 of those cables and the motor will just switch rotation. So okay, we have the 4 motors. They have carbon fiber propellers. These are 11 by 5, so 11 inches diameter and 5 inches pitch, I think it is, or degrees, I'm not sure. And they're going to be giving more or less about 2.8, almost 3 kilograms of thrust each. So that will be good enough to make this hover and climb very nice. So these cables from the motors are all routed at the bottom of the wing. So you can see here they are attached, it's a bit messy, but they're attached to the ESCs, and then the ESCs have a signal wire going to the power distribution board, and then the positive and negative wire, which are also going to be going to the power distribution board. But these ones are same voltage as the battery, which is 14.7 volts. Here on the wing we have the pitot tube for the airspeed sensor. So you have the dynamic port here at the top and then static port on the side. So what the airspeed sensor does is just compare the pressure difference between these 2 ports, and then you can calculate the airspeed. So this is connected to some tubes, which you can see here. These 2 tubes here, 1 and 2. This is the static and the dynamic pressure ports, and those tubes are going to be connected to the airspeed sensor that is somewhere inside here in the fuselage. Okay, so moving on, we have the servos. So this plane has ailerons, elevator, and rudder. It has the option of enabling the flaps, which are these ones over here, but since we have the vertical takeoff and landing capabilities, we don't need the flaps to reduce the stall speed for takeoff and landing, which is good. It could be later implemented if we want to increase the lift coefficient when we're doing a pumping mode or any type of air and wind energy mission. We can just connect these servos to one of the channels in the pig's hog, and we can control it with the remote controller. So these servos, I have to mention here, you have to be careful in order to safely fly. I don't know if you can see it, but these servos are connected to these lever arms, and in order to block it, you have a little piece of hose here, and this prevents the clip from coming off, and then you're losing. If it comes off, you're going to lose the ability to move the control surface, and most likely you're going to end up in a crash. So every time you fly, you need to make sure that the servos are connected, and that the safety, the little piece of hose is attached there, so it's not going to fall. So these servos are powered by 5 volts, and they're coming out of the power distribution board. I'm going to explain later. And then you have the signal wire, which is also connected to the power distribution board. So let's go now to like the fuselage of the plane. So here we have, this is the serial number for Transport Canada. This is the number which the plane is registered, and it's under my name, but in the future we might have to change that because I'm not here anymore. But anyways, I'll let you do that. Here we have the GPS, so it's mounted away from, it has to be mounted away from any power component, so any wire such as this one and the battery one that have like high power going through them. It's going to cause some interference in the magnetic reading of the GPS, so we have to put it at least, it says at least 5 or 6 inches away from the battery. So we have the battery is around down here at the belly, and then you have a linear distance of 5 inches more or less. Then we have the telemetry antenna. So this one, it should be also like 360 degrees, so the signal can go in every direction. So you have to consider that there might be, because there's some limitations in the space. That was the only place that we could mount it. So you have to consider that there might be some interference with the GPS around here. So this area here could be somehow interfered. But anyhow, it has worked so far, and I haven't found any problems. And then back here we have the radio, the receiver antennas, which are going to be receiving the signals from the radio controller, which is the one that I have here. So we have the Turning G9X, and this one is going to be sending the signal to the receiver, which is down here. You have to make sure that these antennas are always 90 in a 90-degree angle configuration. So what happens if these two they come together like this? They're going to basically stop receiving any signal, and you will lose control over the aircraft by remote control. So you have to make sure that this is very well attached. Usually this works pretty well. Just tape it here, and there's also no interference, so no carbon fiber parts or any metal around this. There's no problem around the foam here, because I think it's 2.4 gigahertz. There's no problem with the foam. It's just going to go right through it, and same with the plastic, so there's no problem there. But if you had some kind of carbon fiber plate under this, it will block the signal. So make sure it's 90 degrees and then free of any kind of metal or carbon fiber. So moving on, well, we have the forward motor, which is I believe is a 10-inch foldable propeller. I don't remember the pitch, and this is basically for the forward thrust, and when it's not working, it's basically folded like this, and then when it's on, it will just by itself will just deploy like that and provide the thrust. What else on the outside? So we have the cables going through the wings. You have to make sure that this is nicely here. There's not too many drag, and all the cables where you do the best you can with that mess of a cable there. There's not much that we can do. We had the ESCs inside the fuselage before, but it's a little bit tight inside, so we decided to put it outside. And it's also better because these things can get super hot when they're working, and it's good to have them in the airflow. So they're going to be cooling themselves while the plane is flying. Okay, so I'm going to open up the fuselage so you can see inside. I'm going to put this away for a second. Open this up. There's 4 volts here on the cap, Just need to unscrew them and then pop it open. I actually lost one of the bolts while we were testing the other day. It fell on the dirt and it was pretty hard to find, so I just left it there. Just give it a little push. Okay. So when you open this, you have the pig's hog. It's going to be mounted on this styrofoam base, which comes with the plane. So I basically open a hole which would feed the pig's hog, and it will just be snug there. And the cables are all going down to holes to the power distribution board, which is below it. Let me show you here inside. There's the telemetry system is down there, which is going to be coming out through the fuselage cap with the antenna. So this one here, and it's the only place that you can fit it where it will have a good signal, 360 degrees. So to open the cap, you just need to hit this clip, and then you open it up, and then inside you have the power distribution board, which is this one over here. So it's just a mess of wires right now. You can always go to the diagram and look at all the connections, but basically all the vertical motors ESCs have 3 wires. So you have the positive wire, the negative wire, and the signal wire, which is this one over here. So all the motors are connected from the motor ports 5 through 8. So as you can see, you have motor number 1. I don't know if you can see. You can see here on the prop, and then on the motor there's a number 1. So this number 1 is going to be connected to the port number 5 on the power distribution board. The number 2, which is the one on the back there, is going to be connected to 6, number 3 to the 7, and number 4 to the number 8 port. And then the aileron, elevator, and rudder are connected to the ports. I don't remember this, but it's from 1 to 4, same as the forward motor. It's connected on the port number 3, I think. Anyways, this power distribution board is connected to the battery. So you have the XT90 connector here, which is going to be directly plugged into the battery, which is mounted down there. So I'm going to show you later how I can slide the battery in. Then you power the power distribution board with this cable. It's going to energize the board. It's going to split the 5 volts to the pig's hog. So you have 2 cables going over there, 2 ports. So this is just for redundancy. You have 2 lines, 5 volts going to the pig's hog. You also have the let me see, the I2CA, this port over here, this one here. So this is the one that is going to the airspeed sensor. So that port there, all the wires, it goes to here. And as I told you before, you have the dynamic and static port, and then you compare the pressure difference to measure the airspeed. So you have to make sure that this is pretty well soldered or connected. We had some issues before, and make sure it's reading before you go to the field and do some testing, otherwise you're going to have a bad day trying to figure out what's wrong. Anyways, moving on, we have the I/O power width modulation out. So this is the one that's going to be sending the signal to the vertical motors. So this port here, this port here with the blue tape goes all the way to the one down here with the blue tape as well, and this is going to be spreading the signals to the motors 5 through 8. Then we have the FMEU power width modulation out. It's connected, but I don't think it's not being used right now. It was for a different configuration, but I decided to just leave it like that, just in case I need it for later. What else? Oh, I told you that the servos from the aileron, elevator and rudder are powered by 5 volts, and this is not powered by the picksock but by the BEC of the front motor electronic speed controller. So this one is connected to the 14.7 volts of the power distribution board, which is coming from the battery. But this one here has the BEC. You can see here, I think it's a capacitor there. So this one provides 5 volts in with this signal cable. So this is the one that's going to be connected to these ports here. I don't know if you can see it, it's a bit messy, but when you have the thing in your hands you can actually see it better. So here it's going to be powering this port 5 volts, and then you can connect the servos plus positive and ground to the same row, so you can have 5 volts through all the servos, and then the signal to the motor 1 to 4, depending on the configuration. You can always go back to the diagram to see which one is which. Let me see what else. Another thing that I heard from Stuart is that you need to make sure that the connections, the servo connections, are secure, that in case that there's something moving inside the plane, nothing is going to disconnect. So maybe it's a bit too tight here, so you're not going to be able to see. But the connection from the servos, I put a zip tie in there, so there's no way that that's going to come out. So always make sure that those connections are secure, and if you pull them, they're not going to come apart. I think we're done with the connections. The forward motor is same as the vertical motors. It has the ESC, and the ESC has 2 cables, which is going to be going to a forward motor. Here is pretty straightforward because it will give you the colors of the cable, so you have the red, black, and the blue goes with the yellow. You have no other option, and that will give you the rotation of the motor of the front propeller. What else? So well, the picksock is secured by zip ties. You can see the zip ties there, and they go on top. And same with the GPS. It has this little mount which is 3D printed, and is secured with this very shady piece of plywood with some screws. Maybe we can improve that in the future, but it works for now, so it doesn't matter. And that's about it. Let me show you now how the battery is going to squeeze in. So one other thing that you have to always be aware is just keeping the batteries inside this bag, because they might catch on fire and burn the whole building, so make sure you do that. This bag is not going to keep the fire for too long, but at least it's going to do something. So yeah, make sure you keep them, and then treat your batteries with care. Don't smash them, don't puncture them, and don't look them badly, or they're going to catch on fire. So we're looking for a place to store them. Probably by now we already have them stored somewhere. And yeah, just be careful with them, and especially never charge the batteries unattended. So always be there in case they start to swollen. You disconnect them and take them outside, or put them in a safe container. So if it explodes, you're not going to burn anything. So anyways, I'm going to shut up now, so I'm going to put the battery inside so I can show you. Okay, so that's basically it. You put it with the power cables on the left or on the right, it doesn't matter, and then you push it all the way back until you see that it's not going anywhere. If you want to take it out, make sure you pull it by the tape here. Don't pull it by the cable, otherwise you're going to end up with the cable in your hands, and then the battery is going to blow up. Pull it with here. It's going to bring the battery safely. The other thing that you want to do is put the cables down to through the hole, so you can have access to the cables outside the plane. So in case you need to disconnect the battery as an emergency or just as a convenience, it's easier to do it when it's outside rather than the inside, and then you have to do all this again. So put the battery cable out, put the Esc cable out as well. Okay, so you have the two cables there, and then you can put back all the components in place. So this is a bit messy, but there's some Velcro here, and that's going to make the power distribution board stick in place. Same with the airspeed sensor. I don't have it here. I took it because I was soldering the thing, but I'll put it back. And the Esc, so all that is going to be on the walls there. You can see the Velcro on the walls. Okay, when you hear the clip, make sure that the clip is all the way forward. Everything seems to be in place and not moving, and then you can just put the cap. Also make sure that it clips. If it doesn't clip, bolt. So there we go, we have it. You put the screw here, tighten it up. Same on the back. And side. Okay, so when it's all set up, make sure that this, and I didn't mention this, but this is the tether connection down here. So you have a swivel here, and this is basically attached to one of the wing spars that are crossing the fuselage, which is more or less in the center of gravity of the plane. But like the battery is pushing back towards it, so you'll have to find another way to put this on the sides or maybe around the battery, so it's not interfering with that. And then now here, as I told you, you have the connection to the battery, so you don't have to open the fuselage in order to connect the battery. This is a strap that I should have put inside, so this is to get the battery in place. So when you put the battery, one of these straps is attached to the bottom here, and then another strap to the top. So basically you need to put the strap as a Velcro, so you just strap it to each other and the battery will stay in place. The battery is already like pretty solid where it is, but it's for the inspection. If you want to fly with the Mac club, they require to have the battery secure with this. So anyways, that's there in case we need it. If you don't need it, just grab it and put it inside. Just make sure it's not hanging around when you're doing your test. Okay, so the plane should be ready to connect now and get the motor spinning. But before we do that, I'm just going to unscrew the propellers, because it's not safe to do it. Always, if you're turning on the plane inside the lab and you're calibrating or you're changing the flight modes or doing anything that doesn't require any type of flying, make sure you take the propellers off. You don't want to get caught or break the plane, make it fly inside the tiny space that we have here. So I'm just gonna take one out so I can show you. Then I'm going to pause the video and continue without the propeller. So basically 10 millimeter wrench, you just put it on top here, and you have to grab the motor at the bottom and open it up. Just like that. Just screw this. Please don't lose this. This is the only one that I have. There's another set of there's another pair of propellers, clockwise and counterclockwise, and another set of bolts. But after that, you'll have to order new ones. So anyway, same with the forward motor. So this one, you have to first remove the red cap here. Oops. Okay, should be loose. There we go. And it's the same one as the vertical motors. I think it's standard. I'm not sure. Come out like that. Sometimes it's a bit stubborn, just want to come out. There we go. Yeah, so this one over here is the one that's attached to the shaft here. So this shaft goes in there, and sometimes this gets super hard and it gets super stuck in the shaft. There we go. So you see that there's it's like a pressure connection there. Okay, so I'll take the other propellers off and then continue. Okay, so I remove all the propellers. You have the 4 motors without propellers, 5 motors without a propeller, and then we can connect the battery. So always when I do this, think of the worst case scenario. It can catch on fire, or there might be like a short. So always when you connect this, be prepared for the worst, I would say. So just plug it in and then wait a few seconds. If you don't smell any smoke or you don't hear anything going bad, you can leave it alone, or was just disconnect it right away. So that's the tone for the pixhawk, and everything seems to be fine. I have to wait until it beeps. And now that it's on, we can connect to the ground station. So I also put my laptop on, and we have a mission planner here, and we're going to go here. We are going to connect through COM 8. COM 8, which is a USB. I think it's the USB, and you have to make sure that this is connected and on. So when you do that, you can hit connect on the bottom, on the top right, and you wait until this is connecting.
Bad GPS signal held.
So obviously you are inside. There's not going to be any GPS, which I'm going to tell you how to override it. If you want to arm it inside, you have to wait until the parameters load. So just wait a second. Okay, so the plane is connected. You can see here, this is the horizon, and when I turn this, you can see the horizon moving on the screen. We have a bad GPS signal, yeah, of course, we're inside. And then sometimes you'll have bad AHRS, and that has something to do with the Kalman filter. So you just need to give it a few minutes so it can calibrate itself, and the error will just go away by itself. So once we are connected, we can turn on the remote controller. So make sure that the throttle is always all the way down, and all the switches are pointing away from you. So this up, everything is up, and then once that's on, anyways, if you turn it on and the switch are not all the way up, it's going to complain. But make sure that the throttle is all the way down every time you connect. You turn it on. You can see the green light here, which means that it connected, and the remote controller is connected. So we can actually see, if we go here to initial setup, mandatory hardware, radio calibration, if we move the servos, for example the yaw, you can see the yaw moving, or even for the ailerons, and it's not doing anything on the plane because it's not you haven't pressed the safety switch. So I'm going to show you what happens if I press the safety switch, but not yet. So let's go here quickly through the mission planner. So when you connect the plane, you'll have to go, if you have done any big modification to the plane, you'll have to go through the calibration. So there's accelerometer calibration, which is going to tell you to put the plane in the 6 axis and leave it steady for a little bit until it calibrates. Same with the horizon. Make sure that the horizon is level with the quadcopter frame, not the plane. So that way it's going to hover like a flat, and it's not going to be moving sideways or forward or backward once it's hovering. So yeah, calibrate the horizon with this parallel to the ground. All this parallel to the ground, not the plane. You have to go also through compass calibration, which is done easily by pressing live calibration. It's just going to tell you to rotate the plane in the 3 axes. So you have to rotate it in this direction, and then this direction, and then this direction. So you'll need quite some space to do that. And you do that, you have to see the graph that's going to show here. Once you do that, the compass, the external compass is going to be matching the PICSOC internal compass. So you have to do that, otherwise it's just going to throw you an error. Esc calibration, you can follow the procedure here. It should be ready now, but if you have to do it for some reason, do it again. And then the flight mode. So this is something important. Depending on the flight mission, you have to set the flight mode here. So you have Q stabilize, fly by wire, Q hover, and so on. And those ones are programmed to this switch here. So you have a 3-mode switch that if you switch it, so I'm going to put it so you can see in fly by wire. So as soon as I switch it to the middle, you can see it went to fly by wire. And if I switch it down, it will go to Q hover. So that's good when you have a manual mission. And you can put auto in one of these flight modes and the mission will start automatically, and that's also very good to do. Anyways, that's how you set up your flight modes. So once you have everything set up, you can always go and check the parameters. So you go to configuration and tuning, and then you see the full parameter list, and here you have tons of parameters. So for example, the transition speed is going to be airspeed minimum, I think. I don't know if you can see it. So airspeed fly by wire minimum, this one here. So it's 18 meters per second, and this is the airspeed that the plane will start the transition. So once you get to 18 meters per second, it will slowly ramp down the quad motors, and it will start using the forward motor. No, sorry, The forward motor is already being used to achieve those 80 meters per second, but it will feel that the lift is enough so you can stop using the vertical motors. And same on the other direction. So if you're flying fast and then go to 80 meters per second, this one will kick on and this one will slowly decrease until it shuts off. Anyways, there's a huge parameter list, so I'm not going to tell you all about it. You can always read what parameter means, and always go to the guide and look for the key parameters. So what we're going to do now is press the safety switch. So the battery is connected, so this is energized. Once I press this safety switch, all the servos, the 5-volt components, are going to be energized. Not this one, but the ailerons, elevator, and rudder are going to be energized. So always make sure that the throttle is all the way down and press the switch. Also make sure you have no propellers. Okay, so we're energized, so we can make sure here that the servo rotations are working properly. So we can check the ailerons. So if we press the roll to the right, we want the right aileron to go up and the left aileron to go down. And same on the other way. So if we press roll to the left, we want the left aileron to go up and the right one to go down. Okay, so now we can check the elevator. So I'm not sure if you can see it here. So if we go down, the elevator will go down. There we go. Now if we go down, the elevator will go up to make the plane go up. And then if we press if we pitch down, the elevator will go down. The rudder is not connected right now because we have the arm switch on the rudder. So if I go rudder to the left, it will arm. Rudder to the right, it will arm. Rudder to the left, it will disarm. So it doesn't work right now, but it will work with on the plane mode. Once this is all calibrated, we can also check that the auto servo calibration is right. So if you tilt the plane, you can see that the servos are trying to compensate and stabilize. So if we rotate the plane, let me do it the other way, it's just easier. So if you roll the plane to the right, it will lower the right aileron, so you can create more lift on the right side and then you can balance. Same on the other side. If you roll the plane to the left, it will lower the left aileron. And also with the pitch. So if you tilt the plane up, it will lift the aileron. If you tilt the plane down, it will lower the aileron, so you can stabilize. Once you make sure that that is working, you also have to make sure that the airspeed is measuring. So this guy over here, it has quite a bit of noise. So you can see it's measuring like around 2, and if you blow, it can you can check that it's going to increase. I'm not going to do that, but you can check it. If it's close to 0 or 0, you have a problem. It's probably not receiving any signal. And what happened before is that it was not receiving the 5 volts from the peak sock. So make sure there is some measuring here. You can also see the battery voltage. So you have a 16.7, so it's fully charged. But there is no load. As soon as we turn on the motors, the vertical motors, this will drop significantly. So anyways, let's now arm the vehicle so you can see how the motors spin and how we can control from the quad to the plane. Okay, so let's turn on the motors now that we have checked that the servos are going in the right direction, the elevators and the elevator and the ailerons. The rudder doesn't matter much right now, and now we can just connect these motors here. So make sure that the throttle is all the way down. Servos are working, so the throttle doesn't work yet, but make sure it's down. And then here, this is not going to work because we're inside and we have a bad GPS error here, but still we're going to force it and we can arm it. Make sure you're in a flight mode that is manual, so you don't want auto mode because it will try to start a mission. So Q stabilize is good for now. So we're just going to do arm, disarm, and it's going to tell you we cannot arm because there is no GPS, so we're just going to force arm. Okay, so the plane is armed, and as soon as I touch the throttle, the motors are going to start spinning. So let's touch it. So we have it at minimum now, and we want the motor spinning all the time. So no matter what angle this is rotating, the motors should be spinning all the time. Okay, so make sure it's spinning. Then you can check, for example, that the motor orientation is appropriate. So this is just by hearing. So if we roll to the left, we have to give it some throttle first. Some throttle. If we roll to the left, the right motor should go faster and the left motor should go slower, so the plane rolls like this. And then same for the other side. If we roll to the right, the left motor should go faster and the right motor should go slower. Same with the pitch. If you pitch forward, the back motors should go faster. If you pitch backwards, the front motors should go faster. So once you make sure that everything is working manually, you can always check that the stabilization is working. So you can move the plane around, and if you pitch it to the right motor should go faster to balance the angle, and same with if you pitch if you roll to the left motor should go faster, and same with the pitch. If you pitch back, the back motor should go faster. If you pitch to the front motor should be faster. So anyways, now that this is done, we can I can show you how the fly-by-wire mode works. So if you remember, I set it to the middle switch. So if I switch to fly-by-wire, what is going to happen is that the motors are going to keep hovering and the front motor is going to start providing thrust. So switch to fly-by-wire. So this is going to go to 40% thrust to make the plane hover, and then the front motor is going to start spinning. You don't see it, but it's spinning already. And then now the airspeed is going to be waiting until you get to the minimum airspeed, and once you get to the minimum airspeed, these motors are going to ramp down because it has enough speed to sustain flight. When you want to transition back, make sure you like about hover throttle here, and then you can flip back down to Q hover, for example. Go to Q hover, the front motor is going to reduce speed until it gets to 0, and then this one will go to whatever thrust you have here. So you can play around with that. And that's it. That's the theory of how you fly the plane. So if you want an auto mission, you can go here. Let me shut this off now. So put the throttle down. You can always use this switch. This is the arm disarm switch. I didn't use it because I arm it with the computer, but if you arm it with the remote controller, this will be up, and if I put it down, it will just disarm the motors right away. So it's basically the kill switch, which is important to know. And once we're done here, we can press the safety switch on the top, which will remove the energy from the servo. So now this is not working. So basically the ESCs are going to start beeping because they don't have any signal, and we can now unplug the battery. So let me do that. Okay, so battery is unplugged, and let me show you how an automation looks like here. So we can go to flight plan we have the flight plan, and then all the way here we can load a waypoint file. We can load one of the missions that are already made, so for example number 6. Double click here. Yes, we want to reset the home coordinates, and this is the testing site that we've been testing in Souk. So what we have here is just vertical takeoff, transition to forward flight. We have 4 waypoints, and transition back to hover, and then hover to landing and landing. So you can see down here the mission profile. This should correspond to one of the test cards that's going to be on the concept of operation. So make sure that you match this mission with the ConOps, so that way you're sure of what you're doing the day of the test. So anyways, if you have the flight mission already set, you can when the plane is connected, you can write the waypoints. You hit this. It's not going to work now because it's not connected, but you hit right waypoints and it's just going to send the mission to the flight controller, and then it's going to be ready when you put auto mode. So you go again to initial setup, flight modes, and maybe you can switch one of these modes to auto. Auto. Safe mode is not going to work now because it's not connected, but once you have that, yeah, there's an error because it's not connected. Once you have that, it's going to put the auto mode in the third position here of this switch. So you can arm the plane in manual mode. So for example, Q stabilize, you arm it, you make sure that the motors are spinning at minimum, so the plane is just going to be balanced like this. And then when you're ready for the mission and everybody in the crew is ready, you can flip this, and then the plane will start the automation. So it will basically take off to the whichever altitude you decide, and then it will start transitioning to forward flight, do the waypoint following, and then finally transition back and land. With this automation, you have to be careful with the battery because the autonomy of this plane is not very long. So depending on how much power you use hovering, it's going to last probably no more than 6 minutes. So you have to make sure that those missions are pretty short, and always have somebody to call out the voltage of the battery. And if the battery goes below I'll say like 13.2, you have to take manual control and land it wherever it is, because once it gets below 13, it will just rapidly decrease, and you can damage one of the cells, and the plane is just going to fall out of the sky basically. So anyways, that's it. Something I forgot is that always after each test, remove the battery. So unscrew all this, remove the battery, and put it in the fireproof bag. You don't want anything catching on fire, because you might have some puncture, or the plane had a rough landing or something, and the battery might be compromised. So you have to make sure that the battery is safe on the bag. Okay, another thing that I forgot to mention is how to charge the battery. So we have this ISDT charger. So I basically soldered a laptop transformer. So you have the wall plug connected to the ISDT. So this basically converts to, I think it's 20 volts and 4.5 amps. So these batteries are rated 10C charging, only provide 4.5 anyway. So you can, if you find a better transformer, you can always charge the batteries faster. You also have to be careful. So we plug it in. It's going to start. Okay, so I already have it configured for these batteries, which are 4-cell battery, lithium polymer. But if you want to use it for something else, you can play around with the menu. So you have 4S, the current that you're going to be charging at, the task charge, you can always discharge it if you like, battery type, LiPo, the maximum cell voltage, which is recommended, don't go over 4.2 volts per cell, and that's it. So what we need to do is connect it to the output here. So first we need to connect the balance cable. So this one here goes to the side, just like that, and you can see the voltage of each cell. So it's 3.8 each cell. So let's charge it to 4.2. For that we need this tiny adapter, because this is XT90 and this is XT60, which is inconvenient. Anyways, let's plug it in. It doesn't work with one hand. Plug it in. Okay, it's plugged in, and then we can plug it in here to the charger. Okay, so once it's connected, make sure that all the cables plug is well connected. You have the 4 cell on the screen, and you can press here, start charge. Make sure you're on charge, and then you're in the current that you want. Press start, and it's charging. You'll see, like here, it will go up to 4.5 amps, and you will see the cells increasing to 4.2. Anyways, always charge having the battery under supervision. You don't want to put the battery to charge and then just go. Even these things are pretty smart, and it will just don't go over the voltage, but it could happen that the battery has some defect and it will catch on fire. So make sure you're always looking at the battery while it's charging, always taking care of it. In that case, if it starts to swollen, disconnect it and take it outside right away, or be prepared for any emergency procedure. And that's it. When this reaches the voltage that you want, it's just going to beep one time, and it's going to be ready to disconnect it. So you press stop or cancel or whatever, and unplug it. Unplug always the power cables first, and then the balance cables. And that's it. We have 4 batteries of this. Some of them have their own personality. Some of them, for example, this one of the cells is not pretty well, and then I think number 3 also has one of the cells is not in good conditions. But anyways, they can still be used for flying the plane, at least in short missions. And that's it. And that's it. Hope you can fly this. Don't crash it right away. And well, if you crash it, learn from it and build a new one. And that's it for me. Safe flying. And shoot me an email if you have any questions. I'll be doing my best to reply to all of your questions. And yeah, that's it. Just take good care of the plane. That's all.